So the question that we want to briefly think about is, if I have a function of two variables, f of x and y, then its contours live in the xy plane. Right? So this is the function f of xy equals x squared plus y squared. Its contours happen to be circles. X squared plus y squared equals a constant in the xy plane. And the gradient vector, likewise, lives in only two-dimensional space, because we only have an x coordinate and a y coordinate to take partial derivatives with respect to. So the gradient of a two-variable function is a vector in two space, not in three space. And according to the activity that we just did, we can expect that that gradient vector is always pointing in a direction that's perpendicular to the contour that it originates on. And it always points in a direction along which my function is increasing. But that direction is a direction in two space, not a direction in three space. And so on this three space picture where we're seeing the graph of my function, which belongs to xyz space, the gradient of f is this vector down here on the xy plane. So yeah, it's pointing in a direction that we could interpret as being uphill, but it doesn't have a z component associated with the gradient, right? And so if we want to use the gradient in a more three-dimensional way, then we have to sort of figure out, well, what kind of a z component should we assign to it, right? And it might be reasonable, for example, to assign it a z coordinate that will give the resulting vector a slope that agrees with the directional derivative of the function at that point, so that it does point uphill in a direction that's tangent to the graph. But again, the gradient of a two-variable function is a two-vector, not a three-vector. And so yes, it points uphill, but it does so by pointing within the xy plane and not within xyz space.